Hello everyone, I hope you guys are doing good. So today we'll be discussing another problem of our Blind 75 series. So the problem of the day would be problem 190 of Leetcode reverse bits. So in the given problem, we have been given a 32-bit unsigned integer and we have to reverse the order of the given unsigned integer. Let's say, for example, we have been given n, that's 0, 0, 0, 0. Let's say this goes on and the last three digits are 1, 0, 1. So let's consider all of them as zeros. So we just have to return, our output would be 1, 0, 1, 0, 0, 0. So we just simply have to reverse the order of our unsigned integer. For this, we'll initialize our answer as a 0, or I should say 32 times 0, as we are considering the bit operations here. Now, we have to start getting the bits from the right and append it to the left-hand side of our answer. So the two main problems that we have is, the first is how to get the bits from the right, and the second is how to append the bit starting from the left-hand side. So to get the bits from the right-hand side, what we'll do is we'll perform an AND operation. And we'll perform an AND operation of 1 and n, but our n would be shifted, right shifted, I times. And what would be I in this case? It would depend on which element we are during our loop. So let's say we are running from I equals to 0 to 32. So at I equals to 0, we'll get our rightmost bit, that is 1, and we'll AND it with 1. So ANDing a bit with 1 will give us 1 if we had a 1, and it would give us 0 if we had a 0. So with this, we'll have a bit that would either be 1 or 0. So by doing this, we are able to get our bit from the right-hand side. As I said, that we'll be running from 0 to 32 as we have 32 bits in our unsigned integer. When we'll be at position 1 or at this position, we'll AND it. We'll first shift it by 1. So by shifting this by 1, our n would become, this is shifting by 1, our n would become 0, 0, 0, 0. And at the last, we would just be left with 1 and 0. As the second last position will now be the last position. So we'll get this 0, we'll AND it by 1, and we'll have our bit equals to 0. So by doing this, we'll get our bits from the right-hand side. And the second step to a solution would be to add the same bits to our answer, but from the left-hand side. So for adding our bits from the left-hand side, what we'll do is we'll perform an OR operation between answer and our bit, the bit that we got. But there's a catch again. Like the first bit or the bit from the 0th position that we got from here, we have to append that bit to the 0th or the first position from the left-hand side. So for this, we'll be left shifting our bit 31 minus I time. So as I've shown you here, that right shifts just eliminates the rightmost bit and adds a 0 to the left side. Left shifting a bit just does the opposite. So let's say we had a, we have a certain n, that's 1, 1, 0, 1, left shifting it by one position will just give us 1, 0, 1, 0. So when we left shift our bit by I 31 minus I position, let's say we are doing this for I is equal to 0, or for this one has to go here. So we have to shift our bit from here, its current position, till here. So it will go 31 minus I times. Similarly, the bit at the I equals to 1 position will go 31 minus 1, that is 30 times, and it will reach till here. Similarly, for I equals to 2, I equals to 3, and so on. And how does doing an OR operation works? So a OR operation will return 1 when we have our bit B equals to 1, and it would return 0 when we have our bit B equals to 0. So when we'll do a OR operation for the first position, or when we have 1, our answer will become 1, 0, 0, 0, 0, 0, 0. Now we'll take the second element, or the element at the for I equals to 1 position. Now we'll right shift it by 1 position and it by 1 and get our bit. Our bit would be 0. And now we'll left shift our bit by 31 minus 1, that is 30 positions, and then OR it with this, our current answer. Let's call it current answer. And now after performing the OR operation, we'll still have the same as we had our bit equals to 0. But now for the position I equals to 2, we have our bit 1. So when we OR this by bit shifted to 29 times, or 31 minus 2 times, we'll have 1, 0, 1, 0, 0, 0, 0. Similarly, we can solve the given problem for any n of 32 bits. So let's start with our code. So the code is relatively simpler as compared to the explanation. We'll just initialize our answer to 0. Then we'll start our loop, let's say for I in range 32, because it has been mentioned that we have our unsigned integer of length 32. And now what we'll do is, first we'll get our bit. That would be using the AND operation. But what we'll do is right shift n, the input, by I positions and perform an AND operation with 1. This will help us in getting our bit. That would be either 0 or 1. Now after getting our bit, we'll just perform an OR operation between our answer and the bit that we have, but it would be shifted left by 31 minus I positions. After this, we'll come out of the loop and just return our answer. Let's check our solution. As we can see, this is a pretty efficient solution.